deviation. Okay, to discuss about quartile deviation, first of all discuss what are quartiles and how many quartiles will be there. So quartiles are the data. Quarter means it's a 4 part, means quarters are the data which divide the data into 4 equal parts. It divides the data. If this is the data or the given to you, it divides data into 4 equal parts. We call this as Q1, we call this as Q2 and Q3. Means quartiles are the data which divides data into 4 equal parts. It divides data into 4 equal parts and having 3 quartiles. It will have 3 quartiles which we denote with Q1, Q2, Q3. Okay. Before discussing quartile deviation, because name itself tells, we are going to make use of quartiles. So if you can define quartiles, then calculating quartile deviation is easy. So there are quartiles are the data which divide the data into 4 equal parts, and there are 3 quarters which we indicate with Q1 first quarter, Q2 second quarter, Q3 third quarter. So quartile deviation we indicate with QD. The other name for this is nothing but semi-inter quartile range. Semi-interquartile range. QD is equal to, its formula is Q3 minus Q1 by 2. The difference of third quartile minus first quartile, Q3 minus Q1 by 2. And I said you to write this also, coefficient of QD. How you have defined coefficient of range? Range max minus min by max plus min. Here also the same, Q3 minus Q1 by Q3, the same you are getting with plus Q3 minus Q1 by Q3 plus Q1. Again I repeat, quartile deviation is the second measure of dispersion which makes use of quartiles to calculate the quartile deviation or coefficient of quartile deviation. In general, quartiles are the positional averages which divides the data into 4 equal parts. There are 3 quartiles, Q1, Q2, Q3. The quartile deviation is also called semi-interquartile range. Its formula is Q3 minus Q1 by 2, and coefficient of quartile deviation is Q3 minus Q1 by Q3 plus Q1. So again you will have calculations. This is the basic formula. You will have calculation for ungrouped data and continuous, discrete and continuous data. This is the formula for quartile deviation, basic formula. Now we are going to do the same for ungrouped data, discrete data and continuous data. So let us go to ungrouped data first. Girls, see, we are doing many problems from unit 1. Okay, it's not related to this quartile deviation or anything. Just listen, we are in unit 1. Okay, in the unit 1 we have started with measures of dispersion. I'll discuss the question paper model after finishing at least 50% of the syllabus. Before that, I said you again I'll repeat the same again during the classes also. You have a practical paper and theory paper separately. All these problems you won't get for theory examination. Whatever you are going, the type of questions which you are going to get in theory exam is, then ask what are different measures of dispersion, or write the formula for quartile deviation in ungrouped data or continuous data. Means you won't get any numerical problems at all in statistics for theory paper, where you have a separate practical paper. There you are going to do all these problems. Try to differentiate this, because you are the first year students. Generally all of you will confuse. I think these many problems you won't, not only these many, even a single numerical problem you are not going to get in your examination. Only you get is nothing but definitions and derivations. Here why I am discussing these problems is nothing but those are useful for your practical part. Okay, because we don't have a direct interaction. I am telling you, don't think that all these silly or the small problems you are not going to get in your theory examination. These are very few basics of your syllabus. In the upcoming units you have many theorems or derivations which are important for your theory examination. Don't think all this mean, median, mode and quartile deviation you are going to get for your examination. Okay, all these are basics for your next topics. Got it? Now let us come back again. Ungrouped data. Ungrouped data, I think you don't have any frequencies. These are the number of observations will be given for you on a variable x. So this is the formula of q3 minus q1 by 2, and this is the formula for coefficient of quartile deviation. Then how do you calculate this q1? So what I said, quartiles are the data which divide the data into two equal parts. For calculation of, means you need to calculate q1 and q3. For calculation of q1, you need to calculate q1. Am I right? You need to q1 and q3 is to be calculated. So again let us recall what are quartiles of the data which divide the data into four equal parts. So for calculation of data, how you have calculated median? Just recall. You have arranged the data in ascending or descending order. Then you have considered the middlemost observation as median divides that into two equal parts. Now for the calculation of q1, okay, for the calculation of q1 also, the first step you need to do is arrange the data in like median, ascending or descending order. Arrange the data in ascending or descending order. After that, consider size of into how many parts it's dividing the data. It is dividing into four equal parts. Consider n by 4 or n plus 1 by 4 depending upon the number of observations, even or odd. For calculation of q1. Similarly, for calculation of q3, that is also same. Arrange the data in, if you deal with the problem you will get clarity. Arrange the data in ascending or descending order. So second step, you need to consider size of, as it is quartile, n by 4. I think what is the order of this quartile? q3 stands for third quartile. So third quartile means 3 into, you need to put this third quartile here, 3 into n by 4 or 3 into n plus 4th item in the as ordered series. That gives you q3. Once these two are with you, q3 minus q1 by 2 gives you the coefficient of quartile deviation. Let us do a problem on this. Find out quartile deviation and the coefficient of quartile deviation for following data. (25, 33). Is it a discrete or ungrouped or a continuous data? How can you identify the difference? You don't have any frequency column here. Clearly this is a ungrouped type or ungrouped series, this one. So what is the question? First of all, you should write formula in any problem. Here you need to calculate QD stands for quartile deviation. Q3 minus Q1 by 2. Formula for coefficient of quartile deviation is Q3 minus Q1 by Q3 plus Q1. So let us calculate Q1. So for calculation of Q1, what is the first step? Arrange in ascending or descending order. So arrange the given observations in ascending or descending order. 17 is the first smallest, 20, 25, 33, 35, 45, and first you should arrange either ascending or descending order, it may be. Arrange the data in order. Second one is nothing but Q1 means which quartile? First quartile. First quartile means you should consider size of n by 4. What is n here? Number of observations is 7. So if n is odd, you should consider n by 4, which or otherwise you can consider n plus 1 by 4 also, as it is odd one, n plus 1 by 4, which is nothing but 7 plus 1 by 4th item, which is equal to 8 by 2, 8 by 4th item, which is nothing but second item. In this series, you identify the second one. What is the second observation here? 20. So Q1 is 20. Okay. Now let us calculate Q3. Q3 is nothing but third quartile. Am I right? What are quartiles? Are the data which divide into 4 equal parts. There also you should arrange in ascending or descending order. Then you should consider size of n plus 1 by 4. If it is first quarter, as it is third quarter, you should take 3 into n plus 1 by 4. Means size of 3 into n plus 4 means 7 plus 1 by 4th item, which is equal to 3 into 2, which is nothing but 6th item. Okay, here 1, 2, 3, 4, 5, 6. Here Q3 is nothing but 6th item, here is nothing but 45. So Q3 is 45. Means you have calculated Q1 as well as Q3. Now quartile deviation is Q3 minus Q1 by 2, which is nothing but 45 minus 20 by 2. 25 by 2. Okay. Next, coefficient of quartile deviation is 45 minus 20 by 45 plus 20. 25 by 65. Simplify this, which gives the coefficient of quartile deviation. Thank you.